Archimedes' principle isn't just a theoretical concept. It's used in many real-world applications and continues to evolve with modern technology. Ships float because the buoyant force of the water they displace is greater than their weight. Submarines control their buoyancy by taking in or releasing water from ballast tanks. By filling the tanks, they increase their weight and sink. By emptying them with compressed air, they become lighter and rise. Hot air balloons operate on the same principle. They rise because the heated air inside is less dense than the surrounding air, creating a buoyant force that lifts the balloon. Ship hull designs are carefully engineered to maximize buoyancy and stability while minimizing drag through the water. Different hull shapes serve different purposes, from deep V designs for speed to flat bottoms for stability. Modern technology has automated density measurements based on Archimedes' principle. Precision densimeters use high-accuracy scales and environmental sensors to provide fast, accurate measurements. In laboratory settings, force sensors can precisely measure the buoyant force on objects, allowing for detailed analysis and experimentation. Recent advancements include remote physics laboratories, where stepper motors controlled by Arduino and LabVIEW allow for precise submersion and data collection via force sensors. A novel 3D scanning technique uses Archimedes' principle to measure water displacement at different angles, reconstructing complex objects, including those with hidden features. This offers advantages over optical methods, especially for glossy or transparent surfaces. Researchers are working to integrate surface tension effects into Archimedes' principle for a more unified understanding of buoyancy, particularly important for small objects where capillary forces are significant. The future of Archimedes' principle applications involves increased automation in manufacturing processes with more efficient and precise density measurements. We'll see advancements in submarine design and control, with more sophisticated buoyancy systems for deeper and more efficient exploration. Research will develop a more unified version of Archimedes' principle that integrates surface tension effects, particularly important for microscale applications. And expanded remote access laboratories will enable more students and researchers to experiment with these principles virtually. These advancements ensure that Archimedes' principle remains as relevant in the 21st century as it was when first discovered over 2,000 years ago.